Hi, I'm Karishma Joseph, and this is a short demo for the model which we're using for our risk score analysis project. We're using a bidirectional recurrent neural network, and the dataset we're using to train our model is the Kaggle dataset for toxic text classification. We're building a model using Keras and TensorFlow, and the versions that we're using are these. So on Google Colab, we're using TensorFlow GPU version 2.2.0 and Keras version 2.4.3, which are the latest versions as of now. And once we install TensorFlow GPU, we should uninstall TensorFlow for it to work properly. And on Mac, we're using Keras version 2.4.3, which is the same, and TensorFlow version 2.2.0. And we're not using TensorFlow GPU on the Mac because it does not have GPU support. So I initially had some trouble with the exact versions. And these are some of the libraries that we're importing for text pre-processing and for building the layers. So the word embedding algorithm that we're using is GLOVE. And GLOVE stands for Global Vectors, which is an unsupervised learning algorithm for obtaining vector representation of words. So for example, words which are similar in meaning are close to each other in the vector space and vice versa. And word embeddings are useful when training on data that can benefit from contextual information, such as our case. And this is the pre-processing that we're performing. First, we convert all the text into lowercase, and then we remove special characters and numbers. We try to use text blobs spell check initially to correct the spellings of the words, but this took a really long time to train on the data, so we decided to opt out of it for now. And then we're converting the abbreviations into their full forms. And we're also stemming the words, which is converting the words into their root words. And we're also removing stop words, which are basically words like prepositions, like of, the, etc. So we're using a tokenizer object, which converts sentences into a sequence of tokens, which are either words or characters, such that it's easy for the computer to understand. So fit on text creates a vocabulary index based on the word frequency, and text to sequences transforms each text into a sequence of integers. And this is the model that we're using. We have an input layer, an embedding layer, and a bidirectional recurrent neural network. So we're using GRU because it executes faster than LSTM. So in TensorFlow versions 2.x and above, you don't have to specify CUDN and GRU, which is CUDA's deep neural network. You can directly use GRU or LSTM without the CUDN prefix, and it will use the GPU version. And we're using Adam as our optimizer. And this is how we train our model. So we use k-fold cross-validation to validate the model. And we're also using early stopping such that our model doesn't overfit on the training data. So we monitor the validation loss, and when we notice that the validation loss isn't decreasing further, we stop the training of the model. And finally we train the model. So initially we wanted to use a fold count of 10, but our RAM kept crashing because it ran out of space, I think so. So we settled for fold count of 3. And out of the 3 models that were outputted, we decided to use the second model because it had the highest AUC score, area under the curve score of 0.98. And its validation loss and accuracy was significantly lower and higher. And the model outputs a value from 0 to 1 for each of these classes. And finally, we can save the model to be used later.